previous lesson, I had left a question which you were supposed to attempt as an assignment, and I want to go through the question so that you can mark it for yourself. Now, we were supposed to determine what will be the height when we submerge this, or we make this test tube to float in water in a liquid whose density is 0.8. If I can remember the density, now we assume that the density is 0.8 grams per cubic centimeter. Now, we said that in Roman 3 of this question, we had said that the content of this test tube and the lead shots is the weight is 0.1. That is what we had seen in our previous question. So therefore, we want to determine the height when we have this test tube floating in liquid whose density is 0.8. Now, students, we know that weight is given by, we had looked at this equation, volume times density times G. Now, we know if this is the volume, the weight of this test tube, even if we make it float in another liquid, it will still displace the same weight. So this is the weight of the liquid, this liquid which will be displaced if you immerse this in that liquid. So therefore, our volume or our weight will be 0.1, will be equal to the volume displaced. The volume displaced times, what is the density of the liquid? 0.8. But we can convert this into kilogram per cubic meter. So we multiply by 1,000, and when we do that, we get 800 times 10. So times 10. We want to get the volume of the liquid which will be displaced. Now, to get the volume, therefore, we'll say it is the same as 0.1. You divide by 800 times 10, which is 800. So you can define that using your calculator, student. What do you get when you divide 0.1? You divide by 8,000. When I calculate using my calculator, I'm getting 12 point, not 12, but 0.0000125 cubic meter. This is the volume of the liquid which will be displaced. But we can convert that into cubic centimeters. When you convert, you multiply by 1 million. So when you multiply by 1 million, you get 12.5 centimeters cubed. So that is the volume of the liquid which will be displaced. But our question is asking us about the height in which it will float. And therefore, from our discussion, we had already we know that volume is given by cross-sectional area times height. That is our volume, and we already have our volume, which is 12.5. Our cross-sectional area of this test tube, it was 2. We had, from the question, we had seen that the cross-sectional area is 2. So 2 times the height. Now from there, we want to get the height. So we're making h the subject of the formula. You know now height will be given by 12.4. 12.5 divided by 2. And when you define the 2 using your calculator, you're supposed to get 6.25 centimeter. I hope you had gotten that correct, students. That is the height when we make this content and the test tube to float in liquid whose density is 0.8 instead of the water. Now, students, let's look at our second example on the law of flotation. And I read, you can try to write so that we can solve the question together. Now, the question reads, the figure below, this is our figure, shows a uniform rod. The figure below shows a uniform rod of height shows a uniform rod of height 8 centimeters, the height of the rod, floating vertically in a beaker, containing 2 immiscible liquids, floating vertically in a beaker containing 2 immiscible liquids, P and Q, 2 immiscible liquids, P and Q. The densities of the liquids are, so the densities of the liquids are, we can start with the density of liquid P, are 800 kilograms per cubic meter. The densities of the liquids are 800 kilograms per cubic meter, and the density of Q is 1200 kilograms per cubic meter, respectively. The density of the liquids are 800 and 1200 kilograms per cubic meter, respectively. The cross-sectional area, let me just write cross-sectional area. Cross-sectional area of the rod is 2 centimeters squared. So that is the question. Let's now go to our solution, to the other part of the question. You are supposed to determine part A, determine the weight of the liquid, determine the weight of the liquid P displaced by the rod. Determine the weight of liquid P displaced by the rod. Now, we want to determine the weight of this liquid P, that part which will be displaced when this rod is floating in water. Now, we know that in our previous discussion is that the volume displaced is equal to the volume of the rod which is immersed in that liquid. So therefore, the volume of liquid P displaced will be equal to the volume of this rod which is in that liquid. So from here up to here, that volume will be equal to the volume of the liquid which is displaced. So therefore, we can write that volume of the rod inside P, liquid P, will therefore be given by, we know that volume is given by cross-sectional area times height. The cross-sectional area of this rod is 2. The height which is in liquid P is 2. So therefore, what will be the volume, student? It will be 2 times 2, which is the same as 4 centimeters squared. That is the volume of the liquid P, which is displaced. Yeah, now student, volume is supposed to be in cubic centimeters. Now let's move on. We know that the weight is given by what? The volume times the density times G. That is the weight. And already we have our volume. We have the density of liquid P here. This is the density. And we have the G, gravitational acceleration. So therefore, we can solve our question very easily. What is the volume? Convert this into cubic meter. And if you want to convert this into cubic meter, you're supposed to multiply by 1 over 1 million. So 100, 100, 100. So that you convert cubic centimeters into cubic meter. So therefore, you'll get 4 times 10 raised to power negative 6 volume in cubic meter times, what is the density of liquid P, students? It is supposed to be 800. So it is times 800 times what? What is our G? We know that our G is 10. So therefore, when we solve this question, we get that the weight of liquid P, which is displaced, will be equal to, multiply this using a calculator, you get it as 0.032 newtons. So that is the weight of liquid P, which is displaced. Now, our part B of the question reads, you are supposed to calculate, or you determine the weight of liquid P, determine the weight of liquid P, which is displaced by the rod. So we move by the same steps. The weight of liquid Q, weight of liquid Q displaced, weight of liquid Q, this liquid Q which is displaced. Now we say that we move, we just calculate the same, using the same steps which we have done in Roman 1. So the volume of liquid Q, volume of liquid Q will therefore be given by the volume of the rod which is on that part, which is 2 times 3, which is 6 cubic centimeters. Now let's convert this into cubic meter. So it is 6 times 10 raised to power negative 6 cubic meters. We want to get the weight. We know that weight is given by volume times G times density, and it is the density of liquid Q. So therefore, our weight will be given by 6 times 10 raised to power negative 6 times G, which is 10, times the density of liquid Q, which we had here in our question, which is 1200. And when you try to feed that in your calculator, you'll get that the weight of liquid Q, which is displaced, is 0.072 newtons. So, students, we have been able to get the volume of Q1 P. So I want to leave you with a question, which you will try to do it during your free time. Roman 3 of the same question, you are supposed to determine the mass of the rod, and the last part, you are supposed to determine the density of the rod. Thank you, students, for listening to my session.